Welcome back into another installment of surface area and volumes, basically. All right, that's what we're doing. In this one, we're going into the surface area of solids. All right, so we're going to look at a couple different shapes, see how we can do these surface area problems, and see how we can do them easily, consistently, and efficiently. Let's go ahead and get started. All right, so to start off with, surface area. So surface area is basically the area of all the surfaces, right? Duh. But think of it as like everything that you can touch, put wrapping paper around, or paint. It's basically everything on the outside that you have to take into consideration, all right? So maybe it's, like I said, maybe it's doing some painting on a big surface. You need to figure out what area do you need to paint on. Maybe it's gifts that you need to wrap. Or maybe it is going to be some kind of material that's very expensive that you have to lay on top of something in order to protect it. Whatever it happens to be. All right. So the idea is basically think of everything that you can kind of touch on the outside of an object or everything that is able to be painted. Okay. So if I had a calculator, the surface area would be basically, imagine this was a perfect rectangle, but it'd be this rectangle here, plus this rectangle here, plus this rectangle here, this rectangle here, this rectangle here, and this rectangle here. All right. So you basically take into account every single thing, every single side that you can touch on a three-dimensional object. Now, it's important to note that, going back to basics, the area of a circle is pi r squared, and the area of a curved surface of a cylinder is 2 pi r h, okay? Reason being is because if you unwrapped a cylinder like you did here, well, what ends up happening is that this length right here ends up kind of wrapping around the cylinder, okay? It's a lot easier if you do it live in class, but you can kind of wrap your head around the fact that like this would be wrapped here, and this length would be wrapped here. So if you think about it, this would just be the perimeter of the circle, which is 2 pi r. So that's why this is 2 pi r. And this would be the height of the cylinder because that's where this other guy is, right? So 2 pi r h is going to be your area of the curved surface of a cylinder. Okay, so let's move on to a different shape. Boom. So let's say that the diagram below is going to show us a square-based pyramid. We're going to say that the base has a side of 8 centimeters, so 8 by 8 by 8 by 8, and that M is at the center of the base, meaning it is going to be the midpoint between here and here. Directly below P, so it's right below P, that means it's going to make a 90-degree angle there. And then as well as the MP, meaning the height of this thing is going to be 10 centimeters. And then PN is the height of the triangle CPD. PN is going to be the height of this triangle. CPD. All right. So now let's find the length of AM. Okay. So if I want to find the length of AM, so I want to know what this is. So how do I find that? Well, it's important to note that our base has side lengths of 8. What does that mean? Well, it means that if I were to draw this here, all right, so remember that, let's say, this is a little bit not to scale. Let me go ahead and try that again. Let's go to that. All right, important to know that this makes a 90-degree triangle here. And this is, again, it's not exactly the scale. It's kind of hard to represent it with my iPad right now. But if this whole thing is 8, we're going to pretend that this is perfectly in the middle in the drawing. But we're going to go ahead and see that that is actually going to be 4. And then since this is going to be 8 right here, and M, again, is in the middle, so that means that this is going to be a length of 4. So what does that mean? Well, that means that the square root of 4 squared plus 4 squared is going to be equal to AM just by using the Pythagorean theorem. And that's going to give us the root of 32 as an exact answer, which to 3 significant figures is going to be 5.66. So I'm actually going to go ahead and move this problem up here. Okay, about 5.66 centimeters. So let's find the length of this length right here, PD. So let's go ahead there. So now what's actually kind of funny about this is you could go ahead and solve this, but it's actually easier to recognize that all 4 of these are going to be the same, right? Just by nature of the pyramid. And it's actually going to be a lot easier for me to figure out this height right here because I know that this right here is going to be the root of 32. I want to figure out what AP is right here. Because again, that's the same thing as PD. And I know that this height right here is going to be 10, and this is a right triangle. So with that being said, I know that AP, which is the same thing as PD, is going to be equal to the root of 32 squared, root 32 squared, plus 10 squared, just by using the Pythagorean theorem. And that is going to give me the root of 132. You know what? I'll keep it like that for now. I'll keep it in exact terms. Okay. So let's go ahead and find the length of Pn. So I know that PD is going to be the root of 132. Go ahead and write that right there, root of 132. Okay. Now, that means that this right here is going to be the root of 132, because they're all the root of 132. So now the question is, what is Pn? So Pn is going to be from P down to N, perhaps somewhat obviously, and clearly not one to, all right. So how can we figure out what this is? Well, again, it might help to break this into kind of a half triangle, because right now I'm basically, the way I drew this kind of leads you to believe that I need to take in this side, and then this full side. But it's actually easier if I just take into account one of these triangles. Doesn't matter if I do that one or if I do this one. But let's just say, for sake of argument, I'm going to go ahead and I'm going to use this one right here, this blue one. Okay? And this would be a 90-degree angle. That's the root of 132. I know that this is going to be 4 because it's half of 8. So again, Pythagorean theorem, I know that the square root of 132 squared minus the, minus 4 squared. If I take the root of that, I'm going to be getting Pn as according to the Pythagorean theorem. That is going to give me the root of 116 centimeters. Okay, I'll go ahead and leave it in those terms right now. So now what I want to do is I want to find the surface area of the pyramid. So let's think about this. What do we have that we need to paint or touch or cover? Well, I have a base down here that's going to be a square, and then I'm going to have 4 triangles. I'm going to have 4 triangles. Again, these diagrams can get messy, so maybe it's actually best if I erase it. Okay, that's much better. So I have a base down here, a square, and I'm going to have 4 of these triangles. 1, 2, 3, and then 4. Okay, so what's the area of the base? Well, that's just going to be 8 times 8, so there we go. Now I'm going to add on to that 4 of those triangles. So again, it's important to note that the area of a triangle is 1/2 of the base, and my base is going to be 8, because I know that that is right here. This is going to be 8. And I just found the height, Pn. I just found that that was the root of 116. So you need to multiply this by the root of 116. And then once I put that in my calculator, I'll find out what my exact answer is. 236 square centimeters. That is the answer to square centimeters. That is going to be the answer to 3 significant figures. Okay. So again, I wanted to, knowing that I was going to use this using the surface area, I know that's best if I keep the root in the answer, because that'll give me the exact answer. It's a lot easier to put into the calculator. All right. But let's say I want to find the volume of the pyramid now. Okay. So I know that the volume of a pyramid is going to be equal to 1/3 times the area of the base times the height. So the volume of the pyramid is going to be 1/3. The area of my base is 64. That's the 8 times 8. My height is going to be 10. I actually could have figured this one out before I did any of these other problems. But that is going to head and give me that the volume of the pyramid is going to be 213 cubic centimeters to 3 significant figures. All right. So as you can tell, we're still using a lot of Pythagorean theorem here. We're using the area of the bases a lot, and we're using Pythagorean theorem to figure out missing lengths so that we can figure out what the area of a lot of these triangles are, so we can figure out what the surface area is, and sometimes that helps us go into what the volume is. Okay, so it might seem quite convoluted, but I promise if you practice these enough, you'll figure out that these are actually quite straightforward, as long as you know the proper steps to take and what you are looking for. All right, so practice does make perfect. Thank you all for watching, and I'll see you in the next video.